Suppose 11% of one producer's tomatoes are unmarketable. At the warehouse, an official inspects a simple random sample of 10 tomatoes from a shipment of 10,000. Let X number of unmarketable tomatoes. First, let me check if this is a binomial experiment. How do we check it? We need to check these four conditions. First one, identical trials. Yes, simple random sample of 10 tomatoes, n equal 10. Independent? Yes, here tomatoes are independent. Then third one, success and failure. First go to the random variable x. It is the number of unmarketable tomatoes. How many possible outcomes? 2. What are those? Unmarketable tomatoes and marketable tomatoes. Here x is unmarketable tomatoes, therefore success is unmarketable tomatoes and the failure is marketable tomatoes. Therefore third condition is also satisfied. But what are the x values? X can take any values from 0 to 10. Now go to the fourth condition, probability of success. That means probability of unmarketable tomatoes. It is 11%. Therefore, P is 0.11. All four conditions are satisfied. Therefore, X has the binomial distribution with n is 10 and the P is 0.11. Find the mean and the standard deviation of X. We know that n is 10 and the success probability P is 0.11. Now we can find the mean. The mean of a binomial random variable is n times p. The variance of a binomial random variable is np times 1 minus p. The standard deviation is the square root of the variance. Here 0.989. Now go to the part B. Asking the probability x equals 0. Probability mass function. Here we compare with the formula. Both has equal sign. Therefore, k is 0. Now we know k, n and p. So we can plug the numbers into the formula probability mass function and the probability of x equals 0 is 0.3118. Part C. Find the probability that the sample contains no more than one unmarketable tomatoes. First, let me write down this expression in a mathematical notation. That is probability of x less than or equal 1. Now compare with the probability mass function. In the formula has equal sign, but our case we have less than or equal sign. Therefore, we need to consider the x value less than or equal 1. What are the x values? X equals 0 and x equal 1. So we need to find the probabilities of these two separately. Formula and in our problem has equal sign. Therefore, k first one is 0 and second one k is 1. Now we know k values, n and p. So we can use probability mass function and plug the numbers and get the answer. It is 0.6972. Let me go to the part D. Find the probability that the sample contains at least one unmarketable tomatoes. Again, let me write down this in a mathematical notation. At least mean probability of x greater than or equal 1. Again, compare with the formula. We have greater than or equal, but the formula has equal sign. Therefore, we need to understand the x values. What are the x values for this case? X can be any value 1 to 10. If you are going to do this, it takes time to simplify. But there is an easy way to do. We can use the complement rule. What is the complement rule for this case? We have probability of x greater than or equal 1. So we can write this by using the complement rule as y minus probability of x less than 1. What are the values of x less than 1? That is the probability of x equals 0. We already know the probability of x equals 0. So we can subtract from 1. The answer is 0.6882. That is the probability of x greater than or equal 1.